All right, guys. All right. Welcome, welcome, welcome to Frank Teaches. MLOps. Yeah, my lovely viewers, my lovely viewers. Yes, yes, guys. Yes. So today we will be looking at how to deploy machine learning workloads. Machine learning workloads. All right. Using Kubeflow with Kubernetes. All right. Kubeflow with. All right. So meaning that on my Kubernetes cluster, all right, I have installed Kubeflow, right? So Kubeflow with your Kubernetes cluster, right? But before I go into the nitty gritty, I've already set up a workflow, all right? A workflow that will look so basic, right? The understanding will be so basic, all right, and straight to the point to a beginner. To a beginner, even an advanced user will appreciate this workflow. Let's get started, guys. Right? So now, on my left-hand side, I have an ML developer. All right? An ML data scientist. Let me put the slash. ML slash data data scientist developer. All right? Yeah, I'll explain their function. We have that, and we have our GitHub repo, okay? And we have the MLOps engineer somewhere there. Then we also have the Kubernetes ecosystem, right? And somewhere around here, we have the AWS S3 bucket. AWS S3 bucket. Now, let's talk about their functions and things that we'll be doing right away. All right. So the ML data science developer, what does it do? He develops the ML model. He's a developer. All right. He is a developer. He writes the model. He writes the model. All right. So in this context of operations, MLOps, all right. MLOps is an extension of DevOps. Right? It's an extension of DevOps. The same way that DevOps does not write code, as in application code, right? It's the same way the MLOps engineer does not write the machine learning model development, right? But it is mandatory, it is required that he understands what this guy has written. He understands, he can interpret what this guy has written. However, as an MLOps engineer, you can write an ML model, you can develop a machine learning model. All right. In my class, my students will be able to develop model, get a data set, right? From the data sets, you can develop a model that can make predictions. All right. So in my own class, so my student will be able, all right, to write, to develop machine learning models, right? Now, when the ML engineer is done writing his model, all right, developing his model, he will now push this model to a GitHub repository. That's where this guy's works end. The ML engineer, that's where his job ends, right? So once he does that, now on one side, there is what? The MLOps engineer, right? The MLOps engineer looks at the code, right? Is now ready to deploy the code into, it could be a cloud environment, it could be a Kubernetes environment, all right? Yeah. So let's look at the approaches that the MLOps engineer will follow, all right, in deploying the ML model. First, all right, there are different approaches. You could want to use, you want to use the concept of Python flags to wrap the model as an application. However, this is something that the developer can also do. So him using Python flags is a way of testing the model. All right, you could test the model. You can also test the model by writing, by copy and paste and run the model to see how it operates, right? Great. Now, the next is what if he wants to Dockerize the model, right? He will create Docker file. He will create all these libraries, the Python libraries and the machine learning libraries that he has used, right? The developer has used. He'll create it into a requirement.txt file. Let me show us a typical example of that. GitHub. Let me go to my GitHub account. All right. So let me show you a typical example. I think I have my repo. Where's my ML repo? Something okay, let me make use of this. Now look at this now. I have a Docker file. I have a requirement.txt file. So my Docker file, right? So this is my Docker file. This is what it's doing, right? So this is just a normal conventional MLOps, all right? Conventional MLOps. Great. Sorry, conventional DevOps. Okay. Now we have the requirements.txt file. So these are the libraries that your model are going to use. So you have to bring them in, Dockerize them all into the image. All right. So that is that method, and deploy it and run it as a container. All right. Then from your container, you can start making your words, your predictions. All right. Great. Now, the next thing is you can automate this entire process. Jenkins, Dockerfile, and what? With Kubernetes. All right. Now, the next approach is Kubeflow with Kubernetes. And this is the flow that we are going to look at. Right. So our flow is Kubeflow with Kubernetes. Now, other things that the MLOps has to set up. You have to set up the Kubernetes cluster. Set up Kubernetes cluster. Kubernetes cluster. All right. We set up Kubernetes cluster either anywhere. Now set up a Kubeflow pipeline on the cluster. All right. And create S3 buckets. All right. So this bucket is used for several things. All right. It's used to store your data sets. Now let's pick it one by one. I have my cluster already. So for this demo, I'm making use of kind. CTL cluster info. So if you've not watched my previous video, right? Where is that video? YouTube. Go to my YouTube channel. If you've not watched my previous video, it's time you go and have a look. It's time you go and have a look. That is ML. That's it, guys. Right. So on this video, I showed us how to install. I showed us how to install kind. All right. Kubernetes in Docker cluster. Right. So we'll be using what kind for this demo, right? So I have that already. So my cluster is running what locally, right? That makes sense. That makes sense, right? Great, guys. Now set up Kubeflow pipeline on your cluster. Okay. So now to set up the Kubeflow pipeline on my cluster, I still on the same video, I have explained the different components. Right? There are different components that Kubeflow has, all right? And pipeline is one of the components. However, because of how complex Kubeflow is, all right, it wouldn't make sense I install all the components, right? I will only install the components that I need to make use of. So there are two major ways you can set up components, the Kubeflow components on your cluster. One is either you're installing the entire Kubeflow platform, or you're installing the component, you're installing the components, the services, component by component. All right. We have the KSAR, we have the catlib, we have the registry, you have the pipeline, and a whole lot. It's about 9 components in Kubeflow. Right. So if you've not watched this video, guys, you need to go and watch this video. Building your first Kubeflow pipeline on Kubernetes end to end. Great, guys. Right? Great. So once we've set up that, okay, let me show you quickly. I've already installed that. So if I come to my cluster, if I now say kubectl get pod in namespace Kubeflow, I should have all the pods. All right. So I should have, these are all the pods: cache, controller, metadata, and they are all in running state. You can forget about these ones. These were the pipeline that I created, and the jobs they've completed, and I'm supposed to clean them up. But however, let's continue. Great, guys. Right now, the next is what? Create an S3 bucket. So as you can see, I have an S3 bucket. It's called test MLOps BKT. Now, on this bucket, I've mentioned two folders. A data folder. This data folder is going to hold my what? Data set. Now, I open this folder. I must have uploaded my data set because I'm going to use the data set. Based on the data set, I'm going to what? I'm going to run my predictions, right? I'm going to run my predictions, use my model, create predictions out of the data set, right? So I must have it somewhere located, right? Which is on what? S3. Great, guys. Great. Then after this, we have the model folder. This model folder, after everything has been done, the deployment, all right, the model deployment is successful. I need to package my model as a .pkl file. Pickle. It's called pickle, right? This extension is called pickle. 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 So it's a Python library. It comes along with Python, right? It's a pickle. So the extension is .pkl. All right. So I'm going to what? Wrap my model as, where is that place? All right, S3, right? As a .pkl file, right? But I don't need it here. Yes, let me delete it first, right? So that when we start, you're going to feel it, right? So that was the previous one I did. Copy and delete. We are good. Close. We are good. So it's empty now, right? Yeah. So that is the folder, the model. So once everything is done, S3, the pipeline is going to upload the packaged model to my what? S3 buckets for storage. All right, for storage. So let's continue. Then this bucket will be used to store data sets. It will also be used to upload the packaged model as artifacts. Right now, the next thing is how do we interact? Right? How do we authenticate from Kubeflow to AWS? To AWS S3. So the only way we can authenticate is by what? Creating an IAM credential, right? So I will create IAM credential. Where is that part? So I'll create an IAM credential, right? So yeah, I have my IAM credential. I'm still on now. All right. So I already have my IAM credential already what created, right? Let's go back to our whiteboard. Now, yeah, we're done. Start. Okay. Start adding MLOps deployment flows to your ML model. So this ML model that the developer pushed to the repository, I'll now start having this. I'll now start adding this cosmetics. I call it cosmetics. All right. So the deployment flows are the cosmetics to my ML model. And to do that, we'll be using a tool called Jupyter Notebook. Use Jupyter Notebook for development. And again, I have another video on Jupyter Notebook, which is this. If you don't watch this video, guys, I don't know what you're watching. Jupyter Notebook basics, deploying Jupyter Lab with Nginx as reverse proxy. You will want to try it out, guys. All right, please go and try that out. Okay. All right, guys. Now I'm on Windows machine, and the way I've set up my Jupyter notebook is via Anaconda. Right? I also explained that on this video. You still need to go and watch it to watch it out, guys. All right, watch it out. Then after that, so on the Kubernetes ecosystem, all right, what do we have here? We have Kubeflow pipeline components is deployed to the cluster as ports, which you've already seen here, right? These are the parts of the ML that are already deployed there, right? And the Kubeflow pipeline service is port forwarded to browser access, right? So because Kubeflow, you can't access Kubeflow, you can only access Kubeflow locally, all right? Kubeflow locally. So for that reason, though there's another ingress service which I didn't set up because of space, all right? I don't need to set up all of that. I just need something very simple which I can use to demonstrate deployment, all right, via Kubeflow. So it would be performing a port forwarding. We'll be port forwarding the Kubeflow service. So if I say kubectl, sorry guys, kubectl get service in namespace Kubeflow. We should have all the services, and the service I will be port forwarding is the ML pipeline UI. All right, we'll be port forwarding that service. Okay. After that, we move to S3. On your S3, you have your data set already stored there. Then the data set will be downloaded and used for model development. And finally, your model artifact will be uploaded back to your S3. So guys, this is my ML deployment workflow. That being said, let's get started. I'm going to get started with the ML model, all right, the model, and look at every area that I need to explain. Let's go there, my GitHub repository. So that should be under here. If you need this code, you can always reach out on this video for access to the code. All right. Now, let me explain. I'll copy all of these into my Jupyter notebook. So let's open our notebook. So new Python, right? Go and watch that video, guys. All right, go and watch that video where I dissected, right? I dissected what? Notebooks. Close it. All right, so I'll copy all these guys, man. Copy. 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 Bring it down here and paste that. All right, so I'll explain bit by bit. Now I'm importing KFP. KFP is an acronym for Kubeflow Pipeline. So the KFP is the library, the Python library, all right? The Python library for Kubeflow, all right? Now, from Kubeflow, there's a method called DSL, right? Now, to view all the method, I can create another cell above. To view all the method in Kubeflow, I can say print directory, print what? KFP. So this is going to print. I've not imported. You have to import these first. Import KFP. All right. So this now is going to there. These are the methods, right? And DSL is a method. You can see this now. Is a method in that library. All right. So great. So that's why we're using what? DSL. And import login. All right. Login and import OS are Python level libraries. Python level, right? So they don't need to be installed. So these are external libraries that need to be installed. Great. Now I'll explain. Because we need to authenticate from Kubeflow to AWS S3, right? I've created an S3 an IAM access key and secret key. Now this access key and secret key I have to create them as an environment variables within my Windows machine. Now, however, I could pass this access key and secret key, all right, in plain text. But the issue is that because of security reasons, my access key and um, access secrets does not need to be exposed. So for that, I've created an environment variable in Windows. So let's go to global environment variables. So I'll open my Windows. I'll go to environment variables, right? Now, under system variables, you can add it on either under user variables for the user or system-wide variables, meaning that if I add it here, every user on this machine will be able to use the environment variable. But if I add it here, the environment variable will be just only will be specific to what just the front user. All right. So I added it here. So I created that what's it called? Let's move this. Environment variable. AWS access key ID, which is the value is there. All right. You keep the variable name and the value to the variable, right? Then AWS secret access key, the same thing, right? Click on OK, all right, OK, and OK, and that's it. And that's it. Now, because I need to link Jupyter Notebook to my local system, I'm using the OS library from Python. So OS has a method called getEnv. Let's check that out. It has a method called getEnv. So if I come here and I create a cell, all right, then if I say import what OS, and let's print the methods in that library, you can see there's a lot, guys. I have getEnv. Where can I see getEnv? GetEnv, get size, is there, guys. I can, okay, this is it. getEnv. All right. So getEnv. So we're using what that method in this library to here. All right. So we've passed the access key and the secret key. Now this part is just a check. Right. Obviously, I can put off this part. I don't need it. Just a check to see if your access key and secret key are properly set. Right. They're not too necessary. Right. If they're properly set, then these lines of code are not what necessary. Now comes the Kubeflow component aspects. So now you remember we've already imported from KPFP. Import what DSL. DSL stands for domain specific language. Domain specific language. Domain specific language. All right. So this is a method that Kubeflow uses, right, to set up pipeline components, etc., etc. Now you can see it is coming with an @ symbol. That @ symbol is called a Python decorator. It uses a Python decorator, right? So now I need to wrap the libraries within my code, because now you can see now I'm kind of placing a layer above my ML what's it called, my model development. Now let me just show us my model development in the raw form before I model.py. Let me show us our model, what the developer wrote, right? What this developer wrote and pushed towards our GitHub repository. Let me just show us. Now this is what this guy wrote. It's on here. Okay, vcode one, model.py. So this is what this guy wrote. Very simple. This is what he wrote. This is your package needs up till here, and the second part is the prediction and this part. All right. So let me show us this in how it works. Let me show us this how it works. So I'll copy this. I'll explain this, guys. I'll copy that. Okay. And let me Let me open another. Okay, great. I'll show us how the model works briefly, then we can continue. All right, so that's the model. I paste that. All right, though I don't have this data set locally. I don't know, so I don't have some error. All right, then after that, I think I should have some error. Okay, okay. Yeah, it's looking for these data sets. It can't find it. It's looking for this file. It can't find it. All right, but let me check my directory. I need to let me download it to I'm coming, guys. Print working directory. Prank. Okay. So I have a directory called MLS, change directory MLS. All right. So let's rerun. Do I have it here? I don't have it. So let me download that data sets. Let me download data sets. All right. I just want to show us something, guys. So these data sets, I'm going to download it. Download. So that's gone to my download folder. All right. Open the folder. I will move it to MLS. So here it is. All right. I'll copy it, and move it to my MLS folder. Is this right? So I have it here. So let me paste it there. Paste. So I have my data set there, right? Great. Now let's rerun this pipeline. Sorry, this cell. So if I run this, okay, directory. All right. So the directory has to be MLS and not data. So directory is MLS, and that's I'm inside of MLF, so we don't need the directory, so we are good. So this should run now. So fine. We now have our data set, right? Our data set is with us because I'm inside of what? MLS, and my data set is inside of what? MLS. Okay. I hope I'm still recording. Great. Now the next part is the prediction. So I'll open my app.py and I copy my prediction. Copy, come over here, and let me put in the next cell. Right? Put that in the next cell. Now let me show us the data set already. So let me show us the data set, how it looks like. MLS. So here's the data set. Or at most, let me display the data sets on in here. All right. So let me display the data sets in here. So I will say, okay, it's already here. Let me display the data sets. All right. So I'll say bd dot read, okay, underscore CSV. All right. Rental underscore 1000 dot CSV. Okay. I could assign that to a variable. Let me call df equals to this, right? What was it saying? Oh, sorry. Okay, now I could now display df dot head. All right, so you can see I just printed the first 5 rows of the data set. The data set has different columns. It has rooms, area, and price. All right, it has rooms, area, and price. So today's lecture is not about developing the model. If today's class was about developing the model, then I would have gone further, but I've gone further in depth to explain all of this. But for the sake of clarity, right, I want to touch top level, right, so that you have an insight of what we are doing. All right. Now look at this. Now I have rooms, area, and price. So in machine learning, there's something called features and labels. Features and labels. Features are what defines the objects, the data sets. Why the label are what defines the prediction. All right. Now, based on rooms you can see are features. Area is a feature, right? For instance, now I said, okay, I need an apartment, right? And the apartment, I need 3-bedroom flats. 3-bedroom flat, you're not specifying the features of the room, how the flat will look like. 3-bedroom what flat. Then the square feet area. Square feet area, I need 500 by 500, or as the case may be. So these are features. Then price are the labels. Now, based on your features, I want to what? Determine the price. Based on your features, I want to what? Make a prediction of what the price will be. Now, if you're looking for 2-bedroom flats and a square feet area of 600, what will be the price? That is the idea of this model, right? That's the idea of this model. So now you can see the prediction now. Predictions, model of predicts, right? So I'm passing my values, right, as numpy arrays. If you've not watched my numpy, go and watch it, guys. Go and watch it, right? So now I have, let's look at room. I have two rooms, and the square area is 611. 611. Based on this, what will be the price? What will be the predicted price? Let's run that. So if I run this, it tells me that the price will be based on this data. This is the data already. Based on this data, if I'm looking for 2-bedroom flats with a 611 square feet area, the price you pay for such an apartment is what? $1,099 what? Dollar. You can see, guys. So this is what the developer will develop and give to you. This is what the developer wrote and published to our GitHub repository. This is what I have. So at this stage, I want to start developing the model, right? Using what? MLOps methodologies. I don't know if you get the flow. I'm now using what? MLOps methodology in developing all of this. So that's where we are. All right. I'm explaining all of these. All right. So at this level, because the model is entering a different environment, is now entering into Kubeflow. I'm packaging it in the Kubeflow context. Right. So Kubeflow does not have these packages. However, there is a way you can bring in those packages with the help of what? The DSL.component and packages to install flag. So packages to install are NumPy, Pandas, scikit-learn, and what? Boto3. So we need Boto3 for file upload and download. That's why we want what? A Boto3. Now that stage, the next stage now is we need to pass our environment variables, our access key, as part of the build model, right? You can see this thing that we did here. We are set environment variable. We are bringing them here, right? Access key as a string, secret key as a string. Now the next is importing the Boto3 library. So this is an external library. It didn't come with what? Python. So you have to install it. I've installed all of that. Now import pandas as this. Then pickle. I talked about pickle. So pickle is used for the packaging, to package your model. So you need that library to be part of the process. Then this is where the training begins. All right. So within scikit-learn model selection, there is a class. There's a method called train test split. All right. So all of these, I have another video I'm going to teach, and that video would be model, how to develop a model. In that, I will take my time to explain all of these. Right now, linear regression, because the problem I'm solving, machine learning solves two types of problem. It solves a classification problem and a regression problem. So a classification problem is a problem that has to do with objects, things like animals, classifying animals. Is this animal a cat or a dog? So this is a classification problem. Predict, is this animal a bat or a normal dove? is a classification problem, right? But in terms of a regression problem has to do with numbers, right? Now, the problem we are solving, because we are dealing with numbers, right? Rooms is a number, area is a number, and the price is a number, all right? So we're going to we're going to categorize such a problem as a what? A regression problem, right? Guys, we are flowing. Now, after that comes our bucket parameters, all right? So I need to make some changes. My bucket name is this. My bucket name is test, what's that name? Test MLOps BKT. Test MLOps BKT, right? Now, this data is located, that's data on S3. Data on S3. My data set, look at this one. That's a path. Data, then this file, right? So that's where it's located. Now, my model path will be model slash this particular name. Now, my local data path, right? Since I will be downloading this guy to my local machine, it will be directly inside of my MLS. So do we have our MLS there? Okay, so don't have it. So I will change directory. Let me change directory briefly. Let me remove this. So change, all right, CD, because if I do pwd, pwd, I have Frank, right? So change directly to MLS. I have it there, right? You're good now. Okay, great. So it will download this file into our MLS, which we are already there. Then local model path, right? From my MLS is going to upload this file to your where? Your S3 model S3 path, which is on this location. On this location, right? We'll have our model here, right? Great, guys. Great. Okay, so now we also need to call the S3 Boto clients, right? Letting you know that we are passing this as what? Environment variables. So this is where this is the section that is performing the file upload. All right. So download, sorry, is file download. Download from this bucket. The path, the S3 bucket path is that we've defined here, right? It downloads this file to our local path. Our local path will be what? This guy. So this data set will be made available to the model, all right? So that based on the data sets, we're going to run our ML process, right? We're going to make our predictions or our model predictions, right? So if the data set is not available, then there's no prediction, guys. Okay, there's nothing to work with. Okay, now I'm using pandas, right, to retrieve this, to point to the location of what? Of my data set, right? Then great, then these are these, you're splitting your labels and features into X and Y, and you're performing the splits, the training, all right? You're based on your data sets, you're training and testing the data sets, and this other aspect. Then this part is the packaging. Using the P code, right? You can now what? You can write the model as a file, right? All right. You can now package the model as a file, and that model will be written to this location, local model path, right? Local model path will be inside of MLS, and that will be the file name, right? That will be what? The file name. So once that's been written, then this next part is to upload that file. Upload that file to your S3 buckets, right? Now, all of these, after all of these, we need a pipeline, a YAML file. A YAML file that you are going to use to upload towards to Kubeflow. A YAML file that will upload to Kubeflow. And this part is the pipeline. So this is creating, you're creating a function called rental prediction pipeline, right? And you are using your access keys. And from the Kubeflow, you're importing a compiler. We have to compile the pipeline into a YAML file. So this is where we're doing now. We're compiling this pipeline into a YAML file. So this YAML file has everything we've done here so far, everything in the model, right? So once it compiles it, will create this file in my MLOps directory. Let me remove this one that we have here already. Delete. I also I just needed to show us this. I also remove this. All right, great. All right, so once this file is here, we'll now upload this file to our what? Kubeflow pipeline. We'll go to Kubeflow and create a run. All right, but that being said, let's get started, guys. All right, we've walked us through everything. So let's get started. So I'm going to run this cell, right? And let's look at the errors that we're going to have from this. So I'll run this. Boom, we look good. Let's look at our ML directory. You can see now, this file was what? Downloaded, was created. The YAML file at what time? 8:26 p.m. My local time is what? 8:26 p.m. Let me delete it and redo it. Select it, delete. Right? So I'm going to rerun what? This. I'm done. As my MLOps engineer. I'm running my model, right? So I'll click on run the cell. Created. Let's check. Come over here. It didn't take time. Successful. All right? Successful. Now, it is this pipeline, this YAML file, I will upload to my Kubeflow. To do that, I'll come to my terminal. Where's my terminal? I need to close some things here. All right. So I already have this running. Great. So now let's get the service first. Get service. So these are my services running in my what? Cluster. All right. Now I need to what? Put forward the service name. ML pipeline, right? 8080. Let's go there, right? I hit enter. So let's do it. So it's now port forwarding. All right. So I'll go to my browser, and I think I don't need this anymore. Maybe I'll go to my browser and I'll type localhost column 8080 and hit enter. So once I do this, I have my what? My Kubeflow pipeline, right? So I had this earlier. I should have deleted to clear up the system. All right, that's okay. Let me do some cleanup. I will do it later. Let's finish. Now, pipelines. We have pipeline, we have experiments, we have runs. So pipeline, you are downloading, you are uploading a .yaml file that has the entire pipeline. All right? You're uploading it into Kubeflow pipeline to create an experiment against the pipeline. So in turn, the experiments will create a run, right? From pipeline to experiment, from experiment to runs. Let's start with pipeline. So I'll go to what? Upload pipeline. Then I'll come here, upload file, choose file. By the way, Kubeflow is a product of Google. They have Kubeflow, right? And the beautiful thing of learning Kubeflow is if you go in an environment that uses GCP for MLOps, right? GCP has a MLOps service called Vertex AI. So Vertex AI uses two, let me just explain briefly. So Vertex AI uses two SDKs. Let's come over here. So Vertex AI. So Vertex AI uses what? Two SDKs. The first SDK is Kubeflow SDK, and the other SDK is TensorFlow SDK, right? Because Kubeflow is their proprietary service, and Kubeflow is lighter, right? Kubeflow is more. I think they are trying to promote Kubeflow what, right? So Vertex AI predominantly uses what? Kubeflow. So it means that if you are part of our program, right, and you finish learning Kubeflow, and you go to an environment that uses Vertex AI, right? You can comfortably fit into that system, right? You can fit into what? Such a system. Now let's come back. Let's upload the file. Upload the file, the pipeline file. Here it is. I click on what? Open, and yeah, click on create. So once I click on create, automatically, oh, the pipeline. The name of the pipeline, I'll call it, I've used other names. So let me add double arrow, create. So this pipeline has been created. So it takes me to what? Experiments. That I need to what? Create an experiment. So I'll click on what? Create experiment. So I'll give it the name XPPP, any name, all right? I'll click on what? Next. This name already exists, right? Let me XPPP XP. But just give you something that makes sense, all right? Great. Now I've created an experiment. Now from this experiment, I need to what? Run a run, start my run. Now a run is attached to an experiment, meaning that if you need to do away with a run, you need to first, if you need to do away with an experiment, you need to first delete a run before deleting an experiment. If you don't delete a run before deleting an experiment, all right, your run will get stuck, and there's no way you can delete your runs because the experiment that controls the run is no longer available, right? So it's now cost you to go to the back end to start doing some cleanup. I'll show us that process, guys. All right, I'll show us the process. So let's start our run. So this run has been started. You can see our build model. So let's wait for it to finish running. Because if you click on it, the input is empty, the tax details are empty, all right, and the logs are equally empty, all right. So let's just wait for some time. It takes about 5 minutes, right? It takes about 5 minutes. While it is there, let's be looking at our objects, our model upload. You can see the model upload is empty, all right. So once it's finished running, it will compile it, package it, and upload the model as an artifact to our what? To our S3 model bucket, right? Let's check up. Okay. So at this stage now, if I click on it, you can see that the inputs and outputs, they are already input parameters. So these are my keys, right? These are my SSH keys. I said SSH keys, my access key and secret key. So let's just wait for the run to finish running. Let's wait. It's still running. Still running. Once it's finishing running, you will see a check in here. You see a check as in a good completed. So while this is ongoing, we can check the pod. We can come here, check our pod, look at the service that is get pod. You can see now this is currently running. Right? It's currently running. Let's watch it. Let's watch -W. It's still running. It will go from running to completed. Let's watch it. Let's watch it. So that pipeline is running. That run is running. The run is running. So let's check. We are watching it. Say 2 of 2 completed. It's still running here. Check on. Okay, still running. Let's check. It takes some time, guys. Take some time because you are watching it in real time. Take some time. I hope we are still recording. Great, 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 great. So let's see when to change from running to completed, right? Let's see. It's like a task or a job. I'll say a task, a run, all right? It's a run. So the run creates a temporal container, right? It creates a temporal container. Once the execution is completed, it now terminates, right? It will show completed. So you can see now, is it still running? It's still running. 2 minutes has gone. It's still running. 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 Is it completed? Still running. Still running. Remain small. Still running, still running, still running. Right? So let's watch, let's watch, let's watch. Let's watch, let's watch, let's watch, let's watch, let's watch. Still running. Come on, come on, come on. Or is it done? Let's check. Oh, we have an error. Let's see the error. Let's see the error. Logs. Let's see the error. Oh, okay. Okay, I didn't change. Now, in our data sets, okay, it says what? Raise key error, not found, not in index. Now, you remember when we did something, we checked the columns in our data set. Our data set has rooms, area, all right, and price. These are the columns, right? And they are the expected columns. But right here in our model, we are having square feet. You can see here now. We are passing rooms and the area as features. So it's not supposed to be square feet, it's supposed to be area. That's it, guys. That's it. Let's rerun this to create a new YAML file. Run. That's why it took so long. Now it has created a new YAML file. What's the time? 8:36. Let's go to our ML folder. 8:36 p.m. So I'll upload this guy one more time. I'll come over here. Go to pipeline, right? New upload. Okay, upload. Choose a file. Upload and create. So we don't need to. Oh, sorry. Change the name. Let me put XX. Right. Create. So we don't need to create a new experiment. We can still use the same old experiments for the new run. I'll just go to run. I don't need to create a new experiment. So I'll click on create a run. All right. Now the run, I can give the run a run name. I can say my house underscore run. Right. The experiment, I can choose an experiment. Come here, choose the old experiments we used. So you can use one experiment for multiple runs, guys. Right. So it means that one experiment could be attached to more than one runs. Use this experiment. That's it. That's it, guys. Then the pipeline, choose the pipeline. Pipeline was XS, I think so. XS, yeah. Use this pipeline, right? That's all, guys. That's all. Now start the run. Start the run. So let's check what happened to that guy. It didn't complete, right? 344. Running 2 of 2, right? So Control C. Control C. All right, what is it saying? Not ready. Is it a new one? Now, a new one has come now, it's pending. All right. A new job has come. Control C. All right. So let's check. Right. So where's that job? Completed so fast. You can see now. Completed. We didn't get to see it, but it's completed. Completed. Yeah, this is a job in 37 seconds ago. I'll be this. All right. So now I can see. Wow. Now this is an issue. You see this now because we have runs that are already archived. All right. We have runs that are already archived. So this runs is not actually running it ran the pipeline, but it used a cached data to run the pipeline. So if I go to task details, I should see that the status of this run was what? Was cached. So I'm supposed to see a check here, a good sign as it is here. All right. So for that reason, if we go to our S3 buckets, our model will not be uploaded because the stage for the file upload was not executed because of what? of a cached data. So I need to clear the memory of the runs. You can see now if I go to runs, we have this number of runs. The first one failed. So it's already cached somewhere. So I need to clear it. I need to delete all these runs here, right? To do that, I'll move them to what? To archive. So I'll select everything, right? I'll click on what? Archive. So there at archive, I can delete the runs, right? So we'll go to what? Archives. So these are the archive runs. So I can only delete those runs that have experiment. I'll select this one. Let's delete. Delete. Deleted. I select this. Let's delete. Deleted. I select this. Let's delete. Deleted. Good. We are lucky, guys, that the experiments that I used to create these runs are still available. All right, let's finish our deployment. Then I will show us the kind of challenges we're going to have when an experiment that was used to create a run is no longer available. So let's go back to the pipeline and recreate a new pipeline. Right? Upload pipeline. Upload. Choose a file, and here it is. Right? Create. Name. ZZ. Create. Now experiments, I want to use what I have already, right? So I'll come to runs. Runs, create a run, choose the pipeline, choose this pipeline, ZZ, use this pipeline. Then experiment, use this first experiment, use this experiment. That's all. Start your run. Start your run. All right. So let's wait for this run to finish up. Let's wait, guys. All right, don't worry. That's just let's just wait. So the moment this succeeds, we should see let's check. We should see these are the old one. We should see a file uploaded to our S3 buckets. All right. So let's check. All right, new one just got the container just got initialized 3 seconds ago, right? It's running. All right, pod initializing is still initializing. All right, so let's check. It's now running. All right, 18 seconds ago. Right, let's check. It's still running. 24 seconds ago. Let's check. It's still running. 77955. All right, let's check. It's still running. Let's check. It's still running. Okay. CLS. Let's check. It's still running. Right. It takes about 1 minute and 1 minute and all right. If everything goes as planned, all right, great. So if I open the model, I should see our inputs, outputs, tax details. The status is running. You can see. Yeah, we are good now. Should be good. Should be good. So you can see the status is not showing cached. It's not showing cached because we've cleared the previous runs, right? So once you have a leftover run, right, your new pipeline is going to pick up data, things from there. And once it picks up there, your pipeline will not be efficient, all right? To pick up information from the cached run, and which doesn't look good, right? So always clear your run, right? Always clear your run to have a fresh build process. Now you can see the check. You can see the check. It tells it's different from what we had initially. What we had initially was like a cloud, all right? Was like a cloud. Was like a cloud. All right. Apologies, guys. All right. Yeah. So it was a cloud, but now you're having something that makes sense. So go to tax. It tells us that the status was what completed, and the logs they look pretty well. Yeah, it is okay. Now let's go to our S3 bucket. If I come to the S3 bucket, if I refresh this now, I should see our package model. So this is our model. So this model is what we're going to use now to set up a CI/CD. All All right. So the process is you just need to understand the flow, guys. All right. So at this step, I'm going to stop this session. All right, because this step was to do what? To get us right from when the developer develops his model, right, and pushes the model into what? A GitHub repository. Now the MLOps engineer picks up the model, starts fine-tuning the model. He uses the Kubeflow Kubernetes concept, right, to deploy the model. All right. Now there are things he needs to do. He needs to set up a cluster. He needs to create a Kubeflow pipeline on the cluster, create S3 buckets, and all the necessary uh, cosmetics. All right. Once that is done, all right, he now goes towards his what's it called? His notebook to run, execute the model. All right, it's the model. Now, what all we've done so far is manual in the sense that right from here, right? Because by right, I'm not supposed to come to Kubeflow to upload the YAML file, right? Now, this will be a different video. There's what we call Kubeflow API reference. So with Kubeflow API reference, I can automatically, right, create this YAML file without, and this file will be uploaded from notebook to Kubeflow, and everything will get deployed automatically, right, with Kubeflow API reference. So that will be a different session where we talk about what? Kubeflow API reference. That being said, guys, I want to bring this session to a close. But take notes. So we've been able to successfully, right, deploy a machine learning model, right, fine-tune it, add the necessary connecting paths, and deploy it into what? A Kubernetes cluster. And also package our model as an artifact and move it towards to an S3 bucket for what? For easy distribution. That being said, I want to bring session to a close, and thank you, guys. Thank you. Please leave your comments, leave your questions on this video on our channel. Make sure you like and subscribe. Share, guys. Share, and thank you, and see you in our next episode. Peace out, guys. Peace out. Stop recording.